Alright, this lesson is dealing with implicit differentiation. As we continue to build differentiation rules, you're going to come across situations where you have an equation which is not solved for y or not easily solvable for y. And we still need to be able to differentiate it. And so in this example I've given you right here, you have y cubed and y. It won't be easy to get y by itself, but we still have to find out the derivative with respect to x. So we use what we call implicit differentiation. The first step is to differentiate both sides with respect to x. Now, if you have an x in your term already, as we do right here, then it's the same rules we've always done. The derivative of x squared with respect to x is going to be our 2x right there. But the y cubed and the 4y don't have an x in them. So we're taking the derivative with respect to something that's not there. So the way what we're going to do in this is follow our differentiation rules, just like there was an x in it. So 2y cubed would be, bring the 3 down, giving you a 6, and then subtracting 1 from the 3, giving you a 2, so 6y squared. But we add this additional term right here, the derivative of y with respect to x. That gets added to every one of these that do not have an x in them. So moving down to the right, we see we also have the derivative of 4y. Well, the derivative of 4y is simply 4, and we add the derivative of y with respect to x to the end of that. And at the far side, we have the derivative of 2 with respect to x. We know the derivative of any constant is going to be 0. And so we're left with the equation 2x minus 6y squared dy with respect to x minus 4 dy with respect to x. So once we get to this point, we need to finish it up. And it's going to be very similar to Algebra 1 type problems where we have more than one letter and we get them all on the left-hand side and then undistribute. We're going to move all of our dy dx's to the left-hand side, everything else to the right, and then we're going to undistribute. So the 2x comes over here, and we have it right there. The negative 6y squared and the negative 4 dy were already on the left-hand side, so we left them where they're at. And so we have all our dy dx on the left, and everything else on the right. And we can drop down to step 3 down here and factor out. We can undistribute. We can undistribute both of these guys to right here. So dy dx is outside the parenthesis, leaving behind a negative 6y squared minus 4. Our last step then would be to solve for dy dx, to get it by itself, is to divide by the negative 6y squared minus 4. All of this is going to wind up under here. We're going to divide both sides by that term, winding up with this expression on step 4. Negative 2x over negative 6y squared minus 4. We could deal with the signs at this point. I'm not really going to worry about those. But that is our implicit differentiation right there. Now you may look at this thinking, okay, what's the purpose? What have I solved? I still have an x and a y in the final answer. But if you remember right, the whole purpose of taking the derivative is to find the slope of an equation at a particular point in time. So if I asked you what was the slope of this equation at the point 2, 1, you would simply plug that in for the x, that in for the y, and do your math, giving you a negative 4 over a negative 6 minus 4, which is going to be a negative 4 over negative 10, or a positive 2/5. The whole point of this is at the point 2, 1, the slope of this original equation, I'm going to back up here for you, the slope of this original equation right here is 2/5. All right. Here's going to be a homework for tomorrow. You would probably want to start working on a couple of these just to build the skills in your memory, and we'll finish them in class tomorrow.